All right, so we have different types of solutions. Okay, the first is a solid solution. These are actually kind of cool. These are mixtures with a solid as a solvent. Okay, we're actually mixing solids together. Okay, these happen frequently, actually. Okay, like ice, except ice is generally just water, except you will have other stuff dissolved in it. But a popsicle would be a solid mixture. A popsicle. That always makes me think of that's Sylvester, right? And Sylvester that talks like that. What? Well, no, that is Daffy Duck. Yeah, Daffy Duck. A popsicle. Yeah. So gases and solids, we can have a charcoal filter. Liquid and a solid, for example, mercury and silver. There's mercury in your dental fillings. I know they've discontinued that. Most fillings are porcelain amalgam now, but amalgam is actually used to mean specifically mercury. Then sterling silver is when we had copper and silver, so that's what strengthens your silver. These are called, in particular, solids and solids are called alloys. Okay, and those are solutions of two or more metals. Do you guys remember the samurai sword video? Okay, that's a solid and a solid. When it's the copper, when it's the carbon steel alloy, that makes it strong and flexible at the same time. Okay, so for example, we got 14 karat gold, stainless steel, bronze. One could even argue that the history of metallurgy, that's what this study of this small field right here, this small field of alloys and solutions and solids, that sort of stuff is called metallurgy. The history of metallurgy is the history of the world. It's how we've gone from using just discovering basic metals like iron and copper, okay, or mixing them with, or finding bronze all of a sudden, which is slightly harder than copper, and moving on from there until we found better and better steel and titanium mixtures, to the point where our really high quality, the expensive metallurgy behind like the walls of submarines, and military ships and spacecraft are all very, very complicated metallic mixtures. And that as we become more and more sophisticated with our metal mixing, our technology has also improved, and it's sort of gone hand in hand. So it's been said that the history of metallurgy is the history of the world. Okay, then we have gaseous solutions. The solvent is a gas. In air, nitrogen is a solvent. Why is that? The nitrogen is the most abundant gas in the air, so at about 70%. So it would be the solvent with all of the other gases mixed in it. Okay, let's say liquid in a liquid. Antifreeze, or ethylene glycol and H2O. Ethylene glycol is actually really nasty stuff. It's great for what it does. It has a very, very low freezing point, and so it will keep your engine and keep your cooling system in your car from freezing if, say, you're up in the mountains or something. Okay, or it also keeps it from overheating. It has very low freezing point and a very, very high vaporization point. And so it's an excellent for coolant in your car because it'll stay liquid the whole time when it's cooling you off. However, it's also a biocide. It kills any kind of life that ingests it. Plants, animals, doesn't matter. It kills it. I made the mistake of actually pouring a little bit, dropping some of this onto the grass right next to my driveway. It took about 5 years for anything to be able to grow back in that spot. Yeah. It's nasty stuff. Okay? The really insipid part of this is that it tastes sweet. It has a sweet taste to it. So you could set, I mean, if you really wanted to be a jerk, you could set out a bowl of this stuff, you know, for like a dog or a cat to come eat, and it would kill them. Okay, people do this and they get arrested for it. Because they're jerks. They're immoral, cruel people.
So what is it?
On your skin, you want to wash it off pretty quick, but you know, don't lick it.
How do they find out it was sweet?
We have, I don't know personally that's sweet. I know that it is sweet. The glycol. The glycol is a sugar-based group. So, okay. So liquids that do dissolve in each other are called miscible. M-I-S-C-I-B-L-E. Miscible. It really means mixable, but in particular with liquid, it's miscible. Okay, that's going to sound great on the recording. My S is in my speech impediment.
Did you tell us that you
Yeah, that was me. I still kind of do. So miscible, and then liquids that do not dissolve in each other in any ratio are oil and water, and because they're just so chemically different, the polar non-polar thing, oil and water are immiscible. However, if you shake it up really well, you can create something called an emulsion, and that's a whole other issue. Then you can have solids in a liquid, which would be like Kool-Aid. Which again can kill people. Particularly if you drink the special Kool-Aid. So aqueous solutions then. In aqueous solution, now we've talked about this. You guys have we have a sign for this. Our sign for this is AQ. When you see AQ in your chemical equation, that means it's an aqueous solution, that your solute, the solute that you are working with, the substance you are working with is dissolved in water. Therefore, it is an aqueous solution. It is dissolved in water. Okay, electrolytes are very often in aqueous solutions. Again, bringing us back to our Gatorade. This is why we drink Gatorade. Okay, it is actually a scientifically developed, if you believe the commercials, but it's true, it's actually developed at the University of Florida for the Florida Gators. Okay, and that's why it's called Gatorade. And it was developed for the University of Florida to replenish the electrolytes that athletes use when they sweat. Okay, you use salts. Have you ever tasted your sweat before? I know you have. Okay, everyone has. It's not, you don't drink it as sustenance, but it drops in your mouth. You're kind of like, oh, it's salty. Okay, there's a reason it's salty. Shh. Come on, guys. Yes, I know there is an ick factor to that, but you've tasted your sweat before. Okay, you know that it's salty. Those are salts that are leaving your body that are important for the function of your body, so you need to replace them. And that's how Gatorade was developed. Those are called electrolytes. Because your body runs on electricity, it runs through the motion. Okay, it runs through the motion and the movement of these ions. Okay, that's why your body needs the electrolytes. Okay, those include salts, acids, and bases. Non-electrolytes are solutions that don't conduct electricity. Okay, there are no ions, they're molecular in nature. Okay, those are substances like sugars and oils and a lot of organic compounds. Okay, I didn't do this on the first page, but we need to do this now. We're going to stop here, and you guys need to summarize letter C. All right, so this is how a solution forms. Okay, first, We have salvation. You will find salvation when you have the interaction between a solute and a solvent. Yeah, I have yet to be, I can't maintain that for an entire lecture. I have wanted to do an entire lecture as a Baptist preacher. I really wanted to do that. But I haven't, it takes, there's a rhythm to it. I can't get it with the lecture notes. But that is salvation. Okay? It is called hydration when the solvent is water. So when you're mixing something in water, you are hydrating it. So, your salvation is in your hydration. Can I get an amen? No. There's no other chemistry teacher that does this. There's no other chemistry. I didn't say that. Okay, so energy changes. There's some stuff going on, and I'm going to try and show you guys some energy changes that involve when we make solutions. In fact, it's about time for me to bust out what I got down here. We'll do that. Well, I limited them out. I need to count them out, and we'll need to share them. So, okay, so if we break attractive forces, okay, breaking attractive forces absorbs energy. Okay, in other words, you have to put energy into it in order to break things apart. If you put energy into it, it is called. If you put energy into it, it is called endothermic. There it is. Okay. Okay, if you make attractive forces, if you bring things together and allow them to attract to each other, okay, it will release energy, and the process is then exothermic. Both of these processes occur during salvation. Okay, so what happens when sodium hydroxide and ammonium nitrate dissolve? I think I'll be able to do that demo maybe on Friday. Okay. Yeah, so we'll stop there.